Okay, this is a video on piecewise functions. Kind of an idea that I need you to keep in mind is that what I'm going to graph here and show you is that we're working with parts of functions. So according to the domain, it's going to change which part of which function we're going to be working with. If you could take a look at what I've got for you here, the function x has two different types of functions according to which part of the domain you're looking at. So if you're looking at the x values greater than or equal to 1, that's 1 and to the right. That's going to be this linear 2x plus 1. If you're looking at the x values that are to the left of 1, that's smaller than 1, that's going to be this parabola x squared plus 3. So what we're going to do is we're going to graph that. I'm going to show you that process, and then we're going to evaluate the function at these three values depending on what the x value is in these three examples here. All right, so let's go ahead and get going. I'm going to have to graph part of a parabola and part of a line. All right, so what I like to do is go ahead and graph the whole function and then erase the part that I don't need. And as you get better and better at graphing these, you might not have to do that process. But as we're starting early, I'm going to show you that. So I'll start with the line, this linear function 2x plus 1. Y equals mx plus b tells me that 1 is my y-intercept, and then 2 is my slope, or 2 over 1 for my rise over run. All right, so here we go. I'm going to graph that. I'm going to start at 1 at my y-intercept at the point 1, or 0, 1 rather, on the y-axis. And then I'm going to go up 2, and then I'm going to go right 1. I'm going to get a couple more points up 2, right 1. I'll even go backwards to get 1, down 2, left 1, just so I have a good variety of points here. Now, I don't want to do too much because I do know that I am going to erase a fair amount of this function. All right, and then I'm going to go ahead and graph the parabola now. So I've got x squared plus 3. That means I have the parent function, and then I've moved everything up 3 units. So I'm going to move from my 0, 0 vertex of the parent function. I'm going to go up 3, 1, 2, 3, and then now I'm going to do the rest of my points from my parabola: right 1, up 1, right 2, up 4, 1, 2, 3, 4. Left 1, up 1, left 2, up 4. And then this is my parabola that has been translated up 3 units according to f of x. Okay, so now I'm going to do the erasing portion. Remember that 1 seems to be where all the action happens. Now, I'm not putting this blue line on the vertical line 1, the x value of 1, as an asymptote or anything. It just helps me know where I need to erase, what I need to keep, what I don't. So now I'm going to go to my eraser, and I'm going to erase the parabola portion that's to the right of my blue line. So then I'm going to go back and just draw back in the part that I need. Forgive my art there and try to make it a little bit better for you. All right, there we go. And then now, the other thing I need to keep in mind is right here, x, when I'm looking right here, x is less than 1. That means it does not include 1 for this function. So this should be an open circle right here. So I don't actually use that point. All right, now what I do use at 1 and then greater than 1 is going to be this line. So I'm going to erase the part of the line that I don't need, these points back here. And then I'm going to draw in, and let me undo that part. I think I erased too many. And now I'm going to go ahead and draw in the part of the line that I did need this way. So now I can see the two parts of the graph that I'm going to use. To the left of that blue line is going to be the parabola. To the right of the blue line, and including that x value of 1, is going to be this line. All right, so those are my two pieces of this piecewise function. So as x's are smaller than 1, I've got a parabola, x squared plus 3. As x's are greater than or equal to 1, I've got this line 2x plus 1. And notice that I've only got parts of each graph. All right, so they asked me, is this a function? So, a couple of you guys know about the vertical line test, where I can, draw a vertical line. I don't hit the graph more than twice. One of the things that's critical right here is as you're looking at this, you could see a vertical line, this blue vertical line, and is it hitting my graph twice? And it's tempting to say yes right away. But the reality is that open circle tells me that I don't actually have a point up there. The only point that's at where that has an x value of 1 is this point that's on the line. So when you ask yourself the question, do I have a point that has multiple, do I have a point that has the same x value but different y values? So the same x value shows up twice? You actually do not have that. So this is indeed a function. So yes, this is a function because I don't have any point who has the same x value but different y values. So no x values get repeated. It's still a one-to-one correspondence. All right. Now I'm going to evaluate the function at these different x values. When the x value is -2, what's the functional value? So what I like to do is I just compare this to the domain. -2 is less than 1, so that means I'm going to put it into this function here. 6 is greater than 1, so I'm going to put it into that function there. And 1 is actually equal to 1, so it's going to go with this function as well. So that's what I'm going to do when I plug in. I got to know which piece to plug into according to the domain. So let's go ahead and figure that out. So if x is -2, then that means that I'm going to substitute that into this quadratic. So -2 squared plus 3. -2 squared is 4. And then 4 plus 3 is 7. So what's the functional value when x is -2? 7. All right. What's the functional value when x is 6? Well, 6 is greater than or equal to 1, so it's going to go into the linear. 2 times 6 plus 1, which is 12 plus 1, or 13. All right. And then 1 is equal to 1. Still going to stick with the linear function on that one. 2 times 1 plus 1. So 2 plus 1 is 3. All right, so that's how I graph it. That's how I decide if it's a function. And that's how I can evaluate the function at those points. In closing, I did want to just go through one more piecewise graph with you just to make sure you're seeing all the different pieces. We made it a little more complicated this time and gave you 3 functions, one of which is a cubic. So a little bit more complicated. I went ahead and put the graph on your screen for you so you can see, but just walking through each stage, this -x minus 5 for the section of the graph between -5 and -2 is a line. That's linear. So you can see right here what I've got. -5 to 0 is a line that's got a slope of -1 over 1, down 1, right 1, down 1, right 1, down 1, right 1, and you can see that line. And then at -2, we start a parabola. So we've got a parabola that's been reflected and then translated up 1. So you can see it's been flipped over the x-axis and then moved up 1 on the y-axis. So you can see that parabola there, and that's from -2 to +2. Notice because it's less than symbols and not less than or equal to, these are open circles. Then just after the parabola ends, so at 2, from the section of the graph that's 2 to 4, you've got this cubic that has been translated right 3 and up 2. So that's a small piece of our cubic function that's been translated right 3 and up 2. Notice that it's a less than or equal to x and then less than or equal to 4. So this actually should be a closed circle right here to make sure we stay consistent with what we're telling you. And you can see the 3 different parts of the graph according to the 3 different parts of the domain. So when you're dealing with piecewise functions, it's all about which portion of the graph are you looking at. So you look at these domains here from -5 to -2, that goes with -x minus 5. So that's a line, and you only look at that line for that part of the graph. But if you're looking at another part of the graph, say 0, then that's going to be between -2 and 2, and that's going to be on this parabola somewhere. So when you look to evaluate that function, you would be looking on the parabola. And then finally, the last portion of this graph was between 2 and 4, and that was on that cubic function. So right here, this is a page from your packet. So when you evaluate the key features and you evaluate these functions, you're going to look at the 3 pieces of this graph. If I want to decide if this thing is indeed a function, again, I'm looking, for that. Is there any location where there's an x value that has 2 different y values? And because of these open circles, even though you could see the end of this parabola and the beginning of that cubic function, they seem to have the same x value. Remember, that open circle means that I don't actually have a point that has the x value of 2. So then we're still good on the idea that's a function. Okay, hope this is helpful. Lots of practice is in your packet waiting for you. Good luck.